Hello students, my name is Sumit Mehta. So today we are starting a new chapter named as three-dimensional geometry. Okay, and we'll start this chapter with the term named as direction cosines and direction ratios of a line. Students, in the last chapter on vectors, we have also studied these terms. Okay, so recall from that if a directed line L passes through, let me draw it again that we have discussed there. Okay, so let's say this is a line L passes through origin and it makes angle alpha with your x, beta with y, and gamma with z axis, and these are called direction angles, and cos alpha, cos beta, and cos gamma are direction cosines. Okay, and what are the direction ratios now? So student, any three number which are proportional to direction cosines of a line drs, which is direction cosines. Any three numbers which are proportional to DC's direction cosines of a line are called as DRs. Let's say if L, M, and N are DCs, means the direction cosines, this is cos alpha, this is cos beta, and this is cos gamma. Okay, so let's say A is lambda times L, B is lambda times M, and C is lambda times N. Okay, so A, B, and C are called as direction ratios of the line. So I can take the ratio L by A is equals to M by B is equals to N by C is equals to some lambda, say constant, and if I take the square of L square plus M square plus N square, this also always gives 1. Okay, so these are all about direction ratios and direction cosines. Now let's discuss the relation between the direction cosine of a line. So this is the relation of the direction cosine of a line, means L square plus M square and N square is always 1. Now we will discuss about the direction cosine of a line passing through 2 points. So student, now we will discuss about the DCs or the direction cosines of a line passing through 2 points. Okay, so let's say let L, M, and N are direction cosines of line PQ. Okay, so let's say this is a line PQ and it is making angle alpha, beta, and gamma with x, y, and z axis respectively. Okay, so draw perpendiculars from P and Q to. So let's say this is a line PQ. So let's draw a line perpendicular, and here is also it is perpendicular. Okay, so now we can say that this point, let's say this is your lambda and this also lambda. Okay, so now from this figure we'll get cos lambda is NQ by PQ, which is Z2 minus Z1 over PQ. Similarly, I can write cos alpha as x2 minus x1 over PQ, where alpha is the, and cos beta is y2 minus y1 over PQ. So now I can find out what is PQ. The length PQ is Z2 minus Z1 square. Okay, so the respective coordinates of line, let's say this is x, p and q, and the coordinates are x1, y1, z1, and these coordinates are x2, y2, z2. So this is the length of the line PQ. Okay, so students, this is all about the direction ratios and the direction cosines, and we have also discussed about the relation between these two, and in the next lecture we will discuss some questions on it. Okay, so stay tuned for that lecture on questions based on direction cosines and direction ratios.